It took a lot of moving parts and a lot of effort for us to get a strong and usable Selenium build at Dropbox. And so I'm going to be moving fast today because I want to cover all of the different things that were necessary for us to get a build that delivered a lot of value for our developers and for our customers. What is Selenium? This talk is not, in a sense, about how to use Selenium and all of the things that can go wrong. There are numerous blog posts and libraries, guides, and books. The Harry Percival's book about Obey the Testing Goat has a good section on what can go wrong. I'll only cover a few of the things that can go wrong. What I'll be looking at are the tools that you should be embedding your Selenium test suite inside of to make it stable, predictable, and useful. But as background, for those of you who haven't used it, what is Selenium? It is an API, a library. It's been written for several different languages that hides the differences between the remote control protocols of several different browsers. You get to write a script once and have it run against Firefox and Chrome both. The underlying mechanism is rather simple. You can give it some JavaScript. It will go run it in the main UI blocking JavaScript loop of the in control of the web page, and you will possibly, if you want, be returned a result. The data you send and the data you receive back can be either plain JSON data, the data types that Python and JavaScript have in common, like lists and dictionaries and strings, but you can also get back opaque references to DOM elements that when you say .click, it sends back a message telling the element that the click event should fire. So it's a way to run JavaScript, get some results back, and then do things, click things, and type things, and see what the effect is on your application. We use this to write tests. Here's a simple test I ran against the PyCon CA site where you visit the front page, you make sure Toronto is in the heading at the top, and then you click one of the navigation links. You write code like this, and you run it against each new version and continuous integration of your website, making sure that you don't break any of those properties of your website. Problem: Selenium tests are expensive. You have to bring a browser up. You're speaking to the JavaScript engine through this remote control protocol, and web pages are often not the fastest things as they come up. It can take a second or two or more for some pages to load at Dropbox, and so these tend to be fairly expensive tests compared to a very quick unit test that just runs a few lines of code. This means a first skill you have to develop is to avoid letting unit test thinking creep into your Selenium tests. What do I mean? Well, we have, for example, a flow at Dropbox where you can go in and see previous versions of every file in your Dropbox and click a restore button if you want to get an earlier version back. Well, you can imagine me as a tester looking, or if I'm writing tests for this, I look and I see all those times down the side, 6 p.m., 4 p.m., and immediately I start thinking of edge cases. Does it work for midnight? Does it work for noon? Does it work for leap day? Don't ask that question with Selenium. Instead, write a unit test against the code that comes out with those times so that you can hit all 30 edge cases you'll think of with dates very quickly. Use Selenium as your integration test suite. It answers the question, is the routine that generates the date string correctly hooked up to the front end where what it returns comes out on the screen? It's not a good and efficient way to ask 30 very specific questions about how that date string is generated. Do not use your Selenium test to iterate across edge cases. Yes, maybe edge cases with the UI, but not edge cases with your data. Use unit tests instead. So that's a first skill. If you get beyond that, you'll encounter two really big problems with maintaining a Selenium test suite. First, Selenium tests are flaky. We'll talk about that for about half of this time. Second, Selenium tests are expensive, and at the end, I'll talk some about keeping the expense manageable for your organization or team. What does it mean to be flaky? What I mean is that Selenium makes it easy to write broken tests. Not simply, by broken, I don't mean that the test fails. That's a failing test, and that's often a very simple matter because it's always failing when you run it. A broken test is one that can't decide. A broken test will sometimes be green and sometimes be red, depending on its mood. For example, and Selenium is famous for making it terribly easy to write tests like that. How about we find a navigation link on the PyCon Canada website, click it, and then see if the place we've arrived has the title schedule. This is a flaky test. It's terrible. What's wrong with it? Well, one, what if running.click, sets off a bit of JavaScript or something that posts some usage information back to Google before heading to the next page, and because Selenium is so much faster than you, it actually checks the title while it's still on the previous page before the reload has even properly started. Then you'll get the error that the title is still the front page. On the other hand, maybe you're not that quick. The page reload gets going, but you check for the title before the reload is complete. You'll now be told there's no H1 element. So there are two different ways for this to fail, only one way for it to succeed, and it's like the simplest thing you can possibly write in Selenium. This is what developers try first. The most natural patterns are the most broken because of an asynchronous environment. Humans are bad at async. Doesn't matter how many async questions you put into your Silicon Valley-style whiteboard onboarding interviews, they're bad at async and they will stay bad at async because they're humans. Now, sometimes browser behavior is flaky. I remember the headache we had with, so in Dropbox, when you share a file, if they open it on the web, we render a preview of it. They don't even need Adobe Illustrator or Microsoft Word or whatever it is installed. We render a preview and let you go and comment and mark it up with comments. Graphic designers love this because they can get feedback without the customer needing to install the correct viewer. Problem is, we found that at least for the version of Firefox we were on when I dealt with this last year, that click and drag did not quite fire the same JS when run programmatically as when a real mouse moved over the screen and clicked and dragged. So we had to work around a real genuine difference in behavior that made this test work some of the time and decide not to some of the time. So whether because of inherent problems with your conversation with the browser or because you write apparently obvious but actually broken code, your developers will find that Selenium tests are flaky. That makes engineers sad to have to fix them. A famous quote is, "But the test passes on my laptop," because all the timings are different on their OS X or Linux machine compared to the cluster of machines where we run our continuous integration tests. Engineers will start to ignore red builds. They'll put up a diff, Selenium will come up red, but the unit tests all work. And they'll shrug and say, that's probably not even my fault. It's probably just a flaky test, and will commit a broken diff to the head of master. So you'll get a diff project that looks like this, that is on fire half of each day, that is always burning to the ground, and that developers learn to mistrust. We decided to go on a quest for green at Dropbox. We decided to start adding some armor to our test suite and to our continuous integration to see what happened. We had a simple process. We used Fabricator and Arc, so you'd say arc diff and put up a first version of the diff, and the tests fail. You fix it, run arc diff, ooh, and this time it comes up green, so your friend approves the patch and you say arc land, and it's squashed, rebased, and master is fast-forwarded to that being the new version of Dropbox. It's an awesome feeling. You're like, millions of people will see this tomorrow, or whatever. Problem is that this leaves it up to the developer to decide whether that final testing result was any good. It turns out some developers in a hurry will go ahead and land even if that last round of tests was red, if they are not convinced it is their diff that made it red. So for many of our other testing suites, we introduced a commit queue, things that are deterministic, like our linters, like our unit tests, which are somewhat deterministic. We changed the code so that when you say arc land, it does not land it. It puts it into a queue and starts all of our most crucial test suites running against it, and only if they complete and are green is it actually added to master. Otherwise, you're sent an email with the failures, and are expected to try again. This had, for the tests we made, blocking tests, an incredible change in our culture. All of a sudden, you had pretty good assurance that the most crucial test suites you were running against would be green most of the time. All of a sudden, people started paying a lot more attention to red on those test suites. Problem: how could Selenium ever qualify? How could a test suite that just randomly breaks when it's in the mood every hour ever be qualified to eject our developers' hard work in the middle of a productive day from making it through the commit queue and landing? So we set out on our quest. First, we invented the idea of quarantine. If a flaky test appears, how about we shut it off for the moment? We looked for this pattern, a test that passes on one version of master, fails on the next version, and then magically, without anyone having time to respond to the red build, just goes green again without any effort. A pass-fail-pass is the classic signature of a test that you thought when you wrote it it was a test, but it's in fact a coin toss that comes up with green or red depending on its mood. When we detect that, we automatically add it to a file at the base of the repo called quarantine.txt, and a task is automatically filed for the last developer who touched the test. We keep running it and collecting history so that when someone does come to fix it, we hopefully maybe have 5 or 10 failures for them to look at and compare. But it is no longer qualified to make the build red. We essentially will ignore that test being red because it failed randomly until someone can try to fix it and get it requalified for coming out of quarantine, which means can you change it so that it has a long streak of green within quarantine, and after a week or two we'll optimistically pull it back out and see how it performs. We created an on-call rotation, someone who watches the build and is paged if it breaks, who will look to see which change broke the build, which can be hard to tell, especially with flaky tests. They don't always break as soon as they land. So when you get a broken build, it could be a change 5 diffs ago that caused it and just happened to do 4 good coin tosses before finally flaking. Correlation does not equal causation with tests of this nature, and the on-call has to develop some practice in telling whether to try to find how to find the breakage, decide whether to simply revert, or whether to look for a fix. We added the controversial idea of auto retry. You're running through the Selenium tests, a test fails. Why not just try it over again, right? Give it a second chance. But I can hear you cry. A retry could mask a real failure. Like maybe the UI really breaks half the time for the user, and Dropbox's users will click and get a button that doesn't work some of the time. We made the decision to retry anyway. Before we really declare a build failed, we try each breaking Selenium test twice. What is our reasoning? A damage from a false red is vastly greater than the damage from a false green. A false green, a test that you retry and succeeds, could really have detected a transient failure that occasionally will, hurt that feature on the website. So you potentially have a bug in a feature by doing this. If your build has false reds, the entire build becomes worthless because developers will not trust it. They won't pay attention to it. A build with a few false greens is survivable and for the most part will provide immense value for your organization. A build that is perpetually red provides often very close to 0 value. And so we made the decision to prioritize always having reds be meaningful over and against the possibility that sometimes a transient breakage will make it by and have to be detected either as we are using that version of Dropbox as it goes out to the servers we use, as that version of Dropbox gets canaried out to our canary cluster, or as it then lands and gets seen by the rest of our users. So commit queue, quarantine, an on-call dedicated to the build, auto retrying, and there were a few other tricks. I'll mention one. Block outbound HTTP. One weekend, a bunch of tests all failed. Like 20 tests all broke. turns out when they had been developing a credit card swiping or a credit card workflow, the tests actually went out into the world and hit the test instance of the payment provider, the payment processor, in order to complete the test. So when the provider took their testing cluster down for maintenance over the weekend, our build went completely red. We modified the VM to block all outbound HTTP so that people cannot any longer even land tests that depend on external services. Because if we have a broken build, we at least want it to be because of our servers and not someone else's. Because of all of that armor that we put around the Selenium, the double and triple checks, in January 2015, it's been going for almost a year now, Dropbox's Selenium test suite was approved as a commit queue blocking build and has spent the vast majority of its time being green ever since, because we don't even allow you to land anymore if a Selenium test goes red. So all of those steps made what is normally a completely unreliable source of information basically survivable and something that now people expect to be green and pause and look at if it is not. People are going to write a lot of Selenium tests if it's a reliable mechanism for keeping a service like Dropbox that millions of people rely on working and up and operating for our customers. How can you do it at scale as the test suite grows to an hour, to 2 hours, or to more? First, of course, you'll want to shard it. You'll want to spin up when someone is ready with a diff, 10 or 20 or whatever containers on different machines to start running, each of them, their share of your total test suite to get it done in less time. Remember that it does have diminishing returns because each shard, no matter how many you have, they each need to do their own setup steps to be ready to go. So you'll find diminishing returns that as you go out to lots of shards, you're getting down, hypothetically, where you're only spending a minute per shard running a few Selenium tests, but you're still spending a few minutes in setup, so it's generally not worth it. So watch for that. Efficiency of grows less as you make it larger and larger. As you're balancing that, the fact that a large fleet is not necessarily efficient against the fact that you do want to get test results to your developers as quickly as possible so that their work days provide as much value for them, for you, and for your customers as possible. Because if you think through the expenses, let's imagine a shop getting pretty big with 100 developers, you can throw into a formula like this some fairly reasonable numbers that with a system like this, remember the commit queue, you need to run each incoming diff 3 times. When you run arc diff and post the patch, the tests all run. When it enters the commit queue after you land, the tests all run. And then after it lands, you run the tests again. It's now too late. It's landed. But you at least need to know as soon as possible if another diff that came in at around the same time created breakage. It's unlikely, but you need to know immediately when it happens. 3 complete runs of Selenium per diff, at least, even assuming the person doesn't iterate fixing some tests, can generate quite a bill per year. Here, just assuming Amazon EC2, probably more expensive if you run your own servers in your own server farm. You can easily, as Selenium test suites get bigger, be paying a developer the cost of a developer per year or more, maybe several developers worth for the suite. Is it worth it? Yeah, because it probably, if you have 100 or more developers, or even if you just have a handful, you're probably saving more time by having that automated check telling you immediately of a breakage than having to find out from your customers, hurting their trust, wasting their time, and then having to figure out what you did in the last day broke that feature for them. That's a tough question to answer. It is very, very valuable to know immediately when you've broken a basic feature, but you need to be prepared for it to affect your run rate, for it to be fairly costly. And Here are some, and so I'm going to talk for a moment about some ways to mitigate that. Because, if you are a startup, as we are, it matters to have runway, to have as much time as possible before the plane hits the trees at the end of the runway, I guess is the analogy that's made. And we have done our best as the Selenium test has grown and evolved to keep its costs pared down when we can. And that has been part of a very successful effort you might have seen in the news in June, that we turned the corner. We finally, that moment when you're taking off, when you feel the plane begin to lift and you realize, I'm not going into the pine trees at the end of the runway. That moment happened for us back in June when our CEO announced that we're now free cash flow positive. Our bank account is bigger rather than smaller at the end of every month, the rare moment for most startups. And it was efforts like this that I'm about to discuss to keep the Selenium tests pared down and under control that was a part of making sure our development efforts stayed efficient in terms of cost. First, only trigger the build when you need to. Do not run the entire Selenium suite for every commit. If someone commits to the readme.txt at the top of your repository, don't run all of the Selenium tests. But how can you guarantee, I hear you say, that some piece of code doesn't accidentally depend on that file? You should either use a whitelist of files that get checked out onto the test machine or a blacklist of directories that get removed so that you can make guarantees that, well, edits over in these documentation directories by definition can't affect the build, so we don't rerun the Selenium tests every time someone edits documentation or edits a service that's not even run on the containers that are simulating your service under test. At scale, don't be a purist. Don't be one of those people that says, a Selenium test must sit outside and click just like a user would through creating the test user and clicking through the verification of the email before the test really gets going. Cheat. Instead, cheat. Poke a hole only in the test instance of your service. Create some API endpoints that do things where you can give it some parameters and just through a quick API call say, hey, create a user with both a work and a personal Dropbox account who is a member of 2 shared folders. Go into the database, create that, send back a JSON response with the username, their email address, and when you return that value, set a session cookie so that the test is already logged in as that user. It will save, 10 or 20 seconds per test of not having to click around to create a user, and it essentially serves as a test fixture. Fast forwards the test into a situation where it's already ready to go. When you're running at scale, don't clean up the database. Don't stop to empty out all of the tables. Just have each test create a new user. I was rather shocked when I came to Dropbox because it wasn't how things worked in the shop where I was previously. When I said, so where's the cleanup code at the end of the test? And they said, cleanup code? And I looked, and every time I ran the Selenium test locally, a few hundred users were being created and just left in my local copy of the database. And I said, but that's not perfectly logical. It looks different after I run the tests. And they kind of looked at me funny and they said, Brandon, if Dropbox stops working because there's a few hundred extra users in the database, we have bigger problems than the state of your VM. And they were right. I've now gone for years, almost 2 years, and you never even notice that there's thousands of orphaned users sitting in the database because we're web scale. At scale, it takes too much time to restart the browser for each test. It's very slow. Reuse the browser when possible in the next test. That means isolation gets a little more difficult. You'll have to check for things like, did you know in Selenium, you can open multiple windows. It's fun. You can open several windows, and in one, you can comment on a file and then switch to the other window and see if the comment appeared thanks to the back end forwarding the message around. That means that a test might just leave a bunch of windows open. That could matter for the next test if it's not expecting a bunch of windows to be open. A teardown of every test, don't clean up the database, But in the browser, that carries some important state. Close extra windows, dismiss alert boxes that might block the next action, delete any cookies. Fun fact, delete all cookies has such a great name. That is a lie. It's called delete all cookies. What it does is deletes the cookies for the current domain you're looking at. This is especially damaging if you need to log out to start over again with the next test, and the last test left you stranded on another domain. So what we do, I think we run clear cookies, and then if we're not at the home domain, we move back to it and clear cookies again. That's worked so far, but that was an edge case we didn't know about until we spent a good deal of time chasing down a flaky test. Because the danger of that is the test isn't failing because of anything having to do with the test. It's failing because of the previous test. So unless you open the logs and look at the name of the previous test and think very hard about that previous test, you're going to have no idea where the breakage came from. I said that if a test fails, we retry it. We do give retries a fresh browser. If we run a test and it fails, then to try to get a green, we do let Firefox exit, start it back up, and see if a fresh Firefox with no state inside of it will be able to run it. And then we flag that retry so we can try to fix it later. At scale, just throw away the VM when you're done with it. Rescue some data from it, but don't think, oh, I need to keep them around for 8 hours each. What if the developer wants to come back and experiment with a failure? You don't want to pay on a bad day with a lot of red build for all of the VMs that will be left sitting around. What data should be rescued? Grab the grab the traceback of the failure itself, standard out and error output, anything printed by the test, save that. Take a screenshot not only of the window that was visible, but of all of the windows Selenium had open. The full py.test output, because remember, it could be the previous test that broke this one, and also log file excerpts. In the beginning, we just did the last 100 lines of each log file. Problem, you don't know if those lines were actually output during your test or one of the previous ones. So I added in little lines that, that only grabbed log lines that had been added since your test started. Only the log lines that appeared during your test run. The problem is people would see test output like this and assume, oh, I must have killed this back-end service, and that's why, how did I break the back-end service? I added another feature where it also just grabs like a dozen lines from right before your test started and includes them, because this is very informative if it can be captured. Then you say, oh, it wasn't my test that killed the back-end service. The previous test managed to succeed, but in succeeding managed to clobber a back-end service that I needed. Include a few lines of log from before the test start so you can see it was already broken. We only test one browser. Chrome and Firefox and IE are converging close enough that it's just not worth doubling the cost of this entire CI system just on the off chance that, Firefox does something different. So all of those steps should help you run at scale. I'm at time, I can see, so I'm going to say one last thing. Avoid writing raw Selenium because you really want a wrapper around you don't want people making those raw Selenium calls that fail easily. You want a bunch of automatic stuff to happen every time. And we used to, because you want to say, don't hit the element with this CSS class. How many users go click on things because they have a CSS class? You read the button is what you do. And so they've been doing this for a while over in Ruby. And one of our developers has recently ported and released Capybara so that in Python you can write tests that talk about what's on the screen efficiently rather than talking about CSS classes and other things that don't matter to your users. And then finally, review these slides. Maybe I'll put up a blog post about this. Gating, experiments that get turned on and off. I also have some advice in here for how you should test multiple code paths that you might have in your test suite at once. Capybara plus armor and retries around the tests plus efficiencies at scale let us get a green and reliable build at Dropbox. Thank you very much.